So we're back again with 2.2, now solving two-step equations. We started previously in this chapter with the idea that we were working with opposites, an infamous Paula Abdul song. If you want to check that on Google or Spotify, go for it. But opposites attract, especially when we're solving equations, because sometimes we have to use addition to reroute subtraction or use subtraction to get rid of terms that are positive. We also see the same if we're using multiplication, where if we see a term that's multiplying, we use division. If we see a term that's dividing, we use multiplication. So we use these interchangeably to still try and solve for one variable. So now we'll be using two steps to do that. We're left with the same kind of procedure from the previous section where we have these two players playing. And that goal here is, again, to try and find what we don't know in one of these treasure chests. But now we have three of them. So, of course, we compare and contrast. We say that this has a penny, this has a penny, this has five, this has five. And so now we have three treasure chests left over. And this should be equivalent to everything that's left over here, which in this case would be 1, 1, 1, 1. So we have how many ones? 1, 2, 3, 4, 5, 6 ones. And we have 1, 2, 3, 4 twos. And we also have a 10. Or eventually, we could see that with all of these three treasure chests added together, this should be equal to the sum of 6, 8, and 10. So this should be equal to 24. So this is different than just adding up or getting rid of terms, because now we have to find out how much is in each treasure chest. And so we could use division in this case, because we know we have three multiples of the treasure chest. Think of this like if we're working with multiplication, we undo this using division. Really important to remember these. So if we were to divide both sides by 3, we're left with the treasure chest only having 6 coins in it. So this was a little bit more work than what we had to do previously. We've seen previously the order of operations where we deal with grouping terms. We've seen exponents very sporadically. We've seen multiplication, which we do from left to right with division. And we've also seen addition and subtraction, which we do again from left to right. That's the reason I'm writing these up on top of each other. And so how does this change when solving an equation? So this is different because now we work backwards. And I started to piece this together previously with now subtraction or addition becoming first. This is different than before, notice. So we take this from left to right. If we have to use some of these terms, do that. We then use multiplication or division, and that, or actually, let's call this division, then multiplication. The order doesn't necessarily matter. So we see substitution or addition first. We see division, multiplication next. If there are exponents, we simplify them, but we won't see exponents for a little bit. And then we see parentheses at the end, where if you string all of this together, it spells out SADMEP. Which if you want to draw something for it, you can. A SADMEP, I don't know what a MEP is. You can Google that if you want, but I don't think it's an actual term. And so this is how we solve equations now that deal with two steps, where we're thinking, can we add or subtract anything first? And then finally, can we multiply or divide anything to eventually solve for our variable, which is usually x, because we want to give that some number. So we see here we have 4x minus 5 equals 12. This 5 is the constant that we should try and take care of first, because this isn't attached to x. Again, the goal is to isolate x. So how can we get rid of this negative 5? Well, we know that it's negative, so we would want to use addition to add 5 to both sides. This leaves us with 4x, and the equal sign drops down. 12 and 5 gets us 17. Now what can we do? We have 4 multiplying with x, so how can we take this further? Hopefully you're saying using division. If we divide both sides by 4, we're left with x equals 17 over 4. And we actually can't simplify this further because there are no common factors with 17 and 4, so we're good here. I'll give you a moment for problem 2. So we have 6x plus 8 equals 26. We should definitely be subtracting this 8 from both sides. This leaves us with 6x equals 18. We see that we have 6 multiplying with x, so again, use opposites here. We'll then be dividing both sides by 6. So 18 over 6, we can simplify that to just 3. We see that we occasionally don't always divide in the second step, and we'll soon see that here. So we have 4 minus x over 2, and this equals negative 3. I know that I'm trying to isolate this, and this is kind of hidden away, so this might take some time. So on the left-hand side, are there any constants that I should be moving across? Any numbers without x that we should move along to the other side? You should be saying 4. So, and we'll subtract this 4, so let's take away 4 from both sides. This leaves us with negative x over 2 equals negative 7. Keep in mind, negative 3 and you're deducting 4, so no need to add. And now we're stuck in the sense that we have x dividing by 2, but how do we undo division? Hopefully you're saying multiplication. So if we multiply both sides of this by a negative 2, and I'm going to do negative 2 because this is already negative, I think it's going to make our life easier if we just multiply both sides by negative 2. This leaves us with now positive x equals the product of negative 7 and negative 2, which is 14. So we're good there. As we see for D, we have a fraction, so we're definitely going to need our reciprocal here. This is going to make our life easy if we multiply with reciprocals. So using subtraction, let's get rid of the 5. This leaves us with 3/4 x, and this is now equal to 11 minus 5, which is 6. How can we go from here since we have a reciprocal? Or sorry, since we have a fraction for our coefficient, how can we get rid of that? Hopefully you're saying by multiplying both sides by 4/3. It's totally fair game. We'll soon see that the 4's cancel here, 3's cancel here. This leaves us with x is equal to 6 times 4/3, which we can simplify. 6, we could take away the 3 because it's 3 times 2, so leave 2 here. 2 times 4 would get us 8, which is now x. We'll soon see in the next video that there is a bit more going on with this. With two-step equations, this definitely amplifies what we've seen previously, and we'll talk more about this in class.